Hi, and welcome to the content video for 4.2 equivalent ratios from course 1A Singapore Math. Well, this chapter has 7 things to understand, but they are interrelated, so don't worry. So let's get started with the first part. It says write equivalent ratios to show the same comparisons of numbers. So you have ratios and you have to find equivalent ratios of that to show the comparison. Let's say we have 6 over 12. Okay, I'm going to make the bar model here. That's 1, 2, 3, 4, 5, and 6. Okay. Now we have 12 there, right? So I'm going to make 12 here. That's 1, 1, 2, 2, 3, 3, 4, 5, 6, 4, 5, 6. I know they're not equivalent, but the idea is to explain you the concept. So that's 6, and this together is 12. Now that I want to find an equivalent ratio, what I'll do is I'll take this as 1. Okay, that's second pair, and that's third pair. So when I'm combining two parts, how many parts do I get here? I get 3 parts. Same thing I do with 12. That's part 1, part 2, part 3, part 4, part 5, and part 6. So in case of 6, I took 2 parts as 1. So the same thing I have to do with 12. I take 2 parts as 1. And what does this result into? This is 3 and that's 6. So that's how I find equivalent ratio. Now, for example, here if I take this 3 together as one part and this 3 together as one part, so I have 2 parts here. Same thing I do with 12. 3 parts, 3 parts, right? And this 3 parts and this 3 parts. How many do I have? 1, 2, 3, and 4. So here it would be 2, and that's going to be 4. Okay, so that's how you find equivalent ratios. Clear? Now we go to the next part here. Find equivalent ratios by division. So it's the same thing, we find equivalent ratios. Okay, but here we're doing by division. Here we used bar model, and here we will be using division, no more bar model. And that's again a very simple process. So let's take another number, and there's a reason for that. Let's say 16 over 48 equals to, now I need to find equivalent ratio. So for instance, I say that this is divide by 2. If I do divide by 2 in the numerator, I'm going to do the same thing in the denominator, divide by 2, okay? And this results into what? 16 divided by 2 is 8, 48 divided by 2 is 24. So that's your equivalent ratio. You can do with other numbers, the common factors, right? 8 goes in 16 and 8 goes in 48 also, right? So if you divide by 8 here instead, like instead here you do division by 8, division by 8, what happens? 16 divided by 8 is 2, 48 divided by 8 is 6. So that's also an equivalent ratio. So by division, okay, we use division to get the equivalent ratio. So do you see the difference? So when we do bar model, it's good with small numbers, but as numbers become bigger, this division works better, because then you're not sitting and joining and combining and all of that. You simply identify a common factor to divide both numerator and denominator, that is both the numbers of the ratio, to get an equivalent ratio. That's why I had this bigger number to show that to you. Okay, let's get to the next part. It says use the greatest common factor. Do you remember GCF? Greatest common factor to write ratios in simplest form. I'm going to take the same numbers here. 16 over 48. Now, 16 and 48 both are multiples of 16. 16 can be written as 16 times 1, and this is 16 times 3, right? What's the greatest common factor? 16. So we cancel that common factor, right? And what are we left with? 1 over 3. So we used greatest common factor to write ratios in simplest form. When we say simplest form, it means it cannot be further divided. So 1 over 3. Can you divide that further to get another ratio? You can divide that and get a decimal answer, but not a ratio. They do not have any more common factors. That's why it's in its simplest form. So we use greatest common factor to get the simplest form. Okay. So this method here and this are related, right? Here we try to create as many equivalent ratios as we can. And here we are doing the greatest common factor to get the simplest version of it. Okay, good. Let's go to the next part here. Find the missing term in a pair of equivalent ratios. So we got to find missing terms. Let's take an example. Let's say we have 4 over 36 equals to 9 over something. That's the missing term. How do we know? What do we have to write there? So we got to find the relation here. 4 to 36 is what? How do you reach there? You multiply with 9. 4 times 9 gives you 36. So whatever you did here on left hand side, you are going to do the same thing on right hand side. So you do again here times 9 because that's what you have here. So 9 times 9 is 81. So that's how you find missing terms. Let's take one more example. Let's say this time we have 4 over 36 equals to something missing term over 81. In this case, what do? We will say that from 36 to 4, it's divide by 9, right? Same thing on the right side. From 81, we divide by 9. So 81 divided by 9 is 9. So the missing term is 9. So do you see what's happening here? You have multiplication, you have division. So based on what numbers you have to find, you can use division or you can use multiplication to get the missing terms. Okay, so this is part 4 done. We still have 3 more. Let's have a look at them. Work with tables of ratios. So in this case, you are given a table and you have to just work with that table. So let's create a table here. We write apple and that's oranges, okay? We create the table. Let's say that's 3, that's 5, then we say 6, 10, 9, 15, and the last one here, 12, 20. So we make this table here and we go here further. So that's A as to O, apple as to orange. And then we want the simplest form here. Apple as to orange ratio. You remember from first chapter how you write ratios, right? So this is going to be 3 as to 5, 6 as to 10, 9 as to 15, 12 as to 20. Be careful because I have apple to orange, but if I had orange to apple, it would be other way. So let me also do that here. Let me add one more here and I say orange to apple. So that's 5 as to 3, 10 as to 6, 15 as to 9, and 20 as to 12. Okay, so watch out what ratio we are writing. Is it apple to orange or orange to apple? So this is something that you have to be very careful of. And now the next step here is simplest form. This is simplest. And how do we get simplest form? Do you remember from here? GCF gives you the simplest form, right? So for 3 and 5, 3 as to 5, they do not have any common factor. So we will write 3 as to 5 as it is. And since it's increasing proportionately, the simplest form for all of them will be 3 as to 5. So 6 over 10. This is 3 times 2 and that's 5 times 2. 2, 2 out. What are we left with? 3 as to 5. Then next, 9 as to 15. 3 times 3 and 5 times 3. 3, 3 out. 3 as to 5. 12 over 20. That's 4 times 3 and 4 times 5. 4, 4 out. 3 as to 5. Did you see that? So when the quantities are increasing proportionately, the simplest version of all of them, the simplest form of all those ratios will be same. And if you want to try for this, oranges to apple, try and check. You will get for all of them, the answer is going to be 5 as to 3, this one here. Okay, so this is how you work with tables. You find the simplest form and you also write this ratios. Okay, moving to the next part. Find equivalent ratios involving two sets of ratios. This one, two sets of ratios, not one. Okay, now here we were finding equivalent ratios, right, by division or by bar model, but we had only one pair, but here it says two sets of ratios. So let's understand that. For example, we have A over B equals to 3 upon 4 and B over C equals to 8 upon 11. And we want A as to B as to C. How do we do that? Now here, which one is common? B and B. But is it same? No, here it's 4 and here it's 8. So the process here is this. We write A, we write B, and we write C. This part A has to B, so that's 3 and 4. Then we go here, B has to C, 8 and 11. So first we simply write what is given to us. That's the first thing. Now, because for B we have two values, right? So we are going to work with that and see how those two values relate. How does this relate? 4 times 2 is 8, right? So what do we do here? We will do 3 times 2. So that gives us 6. We take this 8 down and we take this 11 down because this is already 4 times 2. It's done, right? So we took 8 here. And when B is 8, C is 11. So we take that 11 also down. So this is how you find equivalent ratios when you have two sets of ratios. Okay? Whichever term is repeating, you try to find relation between them. Is it multiplication? Is it division? And then you work with the other terms accordingly. So here, because we got relation for 8, we did not do anything to 11. We worked with A over here. Okay, so this is what you do when you have two sets of ratios. And the last we have here is work with descriptions of ratios to find quantities. This is exactly as this one here, missing term that we did. The only difference is this is descriptions. These ratios are not given to you. Description is given. So that's basically real world problems. And we don't do real world problems here. We solve them directly when we do independent practice because that makes it much easier. You have variety of questions to work upon and apply that knowledge. But if you know this well, doing this should not be a problem. So that's it. We have done all the 7 subsections from this chapter. I hope everything is clear to you. Do rewatch if you need further support, and we shall meet soon in the independent practice for this chapter. Until then, keep watching and keep learning. Goodbye.